Hello, everyone joining us around the world, and welcome to our Distinguished Lecturer webinar series. Before we go any further, my name is Kerry Cosby, and I'm the chapter's manager here at the IEEE Computer Society. I oversee more than 500 professional and student chapters around the world and manage our Distinguished Visitors program. Before we get started, I'd like to get a couple of housekeeping tasks out of the way. You can ask your questions in the Q&A, and Dr. Yatun will answer as many questions as he can following the presentation. The webinar is being recorded, and the slides and recording will be made available after the webinar. Today's lecture will be 5 things that you should not use blockchain for. This webinar is co-sponsored by the STC on blockchain. I'd like to introduce our speaker. Dr. Martin Yatun is a senior scientist at Sintef Digital in Trondheim, Norway. He graduated from the Norwegian Institute of Technology in 1992 and received his doctorate in critical information infrastructure security from the University of Stavanger in 2015. He is an adjunct professor at the University of Stavanger and was editor-in-chief of the International Journal of Secure Software Engineering. Previous positions include scientist at the Norwegian Defense Research Establishment and senior lecturer in information security at the Bodø Graduate School of Business. His research interests include software security, security in cloud computing, and security of critical information infrastructures. Dr. Yatun, I'd like to pass the floor to you.
Thank you, Kerry. Welcome to this webinar. Now, first of all, I'd like to say, make a small comment on ICOs. So ICO is an initial coin offering, and in other words, it's a license to print money. But beware, the I is optional. Next, a bit of terminology. What is crypto? On the right of this slide, you can see a typical Feistel cipher, as in the data encryption standard. This is crypto. On the left, you see Bitcoin. Bitcoin is an example of a cryptocurrency that is not crypto. So don't be that guy. Anyway, so what is blockchain? As the name suggests, a blockchain is a chain of blocks. In this slide, you can see an example of a Bitcoin-type blockchain. If we look to the left, the first block consists of a number of transactions. Each transaction is then processed in a so-called Merkle tree, at the root of which we have the Merkle root. And this is then passed on to the next block, contains a hash of the previous block header, and so on. Now, the trick here is, of course, that once such a block has been committed to the blockchain, it's not possible to change any information without this being noticed. And this is why we call the blockchain tamper evident. Now, the problem, of course, this is easy enough, but the tricky thing is about the consensus. And as often is the case, the devil is in the details. So those of you who spend your time following the roller coaster that is the Gartner hype cycle have been able to, in the last few years, notice that the blockchain keeps cropping up and it keeps traveling along the curve. Now, in 2016, you had things like smart contracts, digital currencies, blockchain regulation, the blockchain itself on the rise, whereas Bitcoin already was thought to be in the trough of disillusionment. The following year, still find some of these examples, but strangely, Bitcoin simply disappears. And then in 2018, we have similar situation. Right, where you have suddenly blockchain for data security, And the blockchain is again on entering here the trough of disillusionment, whereas you have this exciting concept as quantum computing also on the rise. And it is really keeps getting confused. Whoops. Now, if we look at this rising slope, there you have digital cryptocurrencies fiat, so to speak, state-sponsored cryptocurrencies, whereas cryptocurrencies in general are still in the trough of disillusionment. So, speaking of quantum computing, this is actually an important concept when it comes to, or it will be an important thing when it comes to blockchain, because once you have a workable quantum computer, all digital signatures which are commonly in use in today will be broken. So all the digital signatures that typically sign the transactions on the blockchain will be broken. And also all hash algorithms will need to double their hash sizes. This is in respect to something known as the birthday paradox. For more details on this, feel free to refer to this paper in the link below. So in practical terms, all the blockchains that are in common use today will break once you have a quantum computer. This is something to keep in mind. And I mentioned consensus algorithms. Now, there are a number of consensus algorithms which are used in the blockchain. Maybe the most famous one is known as proof of work, which is the one that's used in Bitcoin and also in Ethereum. And the problem, of course, with proof of work is that it's a lot of work. And examples that you may have heard is that the current power consumption of the Bitcoin network exceeds the annual power consumption in the whole country of Ireland. The other popular consensus algorithm is proof of stake, which is, some people claim, it's a problem that only people with the cryptocurrency actually are allowed to play, and so the rich get richer. Then you have the round robin type of consensus algorithms, and here the question is if there are crooks that can make instances faster than you or not. Additional consensus algorithms include proof of elapsed time and Byzantine fault tolerance. Now, this is complicated stuff. And there's a reason why distributed consensus has been a hard problem for half a century. It's very difficult to get right, and it doesn't necessarily scale. And speaking of Bitcoin, now, as you may have heard, it's generally no longer the case that most Bitcoins are mined by single individuals in their basements. Now, typically, Bitcoin is mined by mining pools. And looking at this graph, we can see that the three biggest mining pools, should they decide to collude, they can actually break the 51% security assumption that Bitcoin relies on. So that implies that if these three biggest mining pools cooperate, they can basically rewrite the blockchain. And of course, we also have the Bitcoin price fluctuations. Now, just looking at the last 6 months, this is a bit of a challenging situation, because imagine if you bought into Bitcoin at midway in this graph, and then suddenly you would find your investment halved in a matter of days. But of course, they climb back up again. But this is something we will return to in terms of whether or not you consider Bitcoin to be a currency, or rather more like an investment vehicle. So in 2017, Gartner published this set of strengths and potentials, and I think that we could go through all of these, but I won't. So the most interesting one, or the most important strength, is this first one, which is trust among untrusted parties. So, for instance, in the case of Bitcoin, the blockchain enables people who don't trust each other to do transactions without having a trusted intermediary. And on the potential side, we have various things such as scalability, time transactions, the smart contracts already mentioned, and of course, new business model enablement. And of course, finally, blockchain is or could be a hedge against censorship, because once information is on the blockchain, no government can remove it. So that could be a good thing. But the big question is, do you need a blockchain? Luckily, a couple of smart guys called Wust and Gewijs, they have provided a flowchart that can help us with making this decision. So first of all, do you need to store state? If you don't, then you don't need a blockchain. Then you can just use a database. But if you use if you need to store state, okay. Are there multiple writers? If there are not multiple writers, again, you can simply use a database or whatever. If you have multiple writers, maybe you will need a blockchain. Can you use an always online trusted third party? If the answer is yes, then you don't need a blockchain. Then you simply trust your online trusted third party. This could, for instance, be, so as an example, do you have a bank that you trust? You can trust your bank. In that case, you don't need a blockchain. However, if you don't have a trusted third party, you might need a blockchain. Then, are all the writers known? If the answer is no, then a permissionless blockchain could be for you. If all the writers are known, then you need to know, are all the writers trusted? If the answer to that is yes, then again, you don't need a blockchain. You can just use a database or whatever. If all the writers are not trusted, then you need to decide whether you need public verifiability. If the answer is yes, then you might need a public permission blockchain. If the answer is no, then you could use a private permission blockchain. There have been a number of other such flowcharts. For instance, one was published in IEEE Spectrum, and then also NIST did a special publication for which you can find the link to the left of the slide. They are all basically along the same lines that I just quoted from Wust and Gewijs, but I might recommend you that if you haven't read this NIST special publication, that this would be a very good starting point to have a foundation in blockchain. So I highly recommend that. But one important thing to remember is that blockchain is not your only tool. So think about that flowchart. Try to figure out whether you really need a blockchain. And if the answer is no, then you probably shouldn't use a blockchain. And in the spirit of that, we will now move on to those 5 things that I promised to talk about. So the first thing is that online voting is not something that I believe blockchain is suitable for. You still need to trust the central authority. So this is your trusted third party right there. And this trusted authority needs to create ballots, needs to authenticate voters, etc. And there are also other possible security concerns. Another thing that I might mention is that if you wanted to use the blockchain for online voting, then there's this issue with things being on the blockchain, and it's voter anonymity is something that you can't necessarily easily achieve on the blockchain. So the next thing that doesn't necessarily work with blockchain is supply chain management. Now, this is a pet peeve of myself, because if all parties can be trusted to contribute to the final product, why should they not be trusted to write the supply chain data? And there's also this interface between the physical and the digital world. One thing is, of course, that you can have a blockchain where you can verify that a certain piece of information has passed through a number of checkpoints along the way. But you still don't know whether this piece of information, this certificate, if you will, actually is connected to this physical thing that goes along the supply chain. So, for instance, there have been several proposals to use blockchain to detect counterfeit drugs, but how do you know that this information on the blockchain is actually connected with this physical drug that you are trying to prove has not been counterfeited? Definitely, there are some things you can do here, but you would need to have some additional mechanism that can ensure that there is no duplication of data. You need a link between this physical world of the drug itself and the blockchain. There's also been some proposals about implementing the Internet of Things with blockchain. Again, here we have the interface between the physical and the digital world. Now, if you have a sensor, etc., and you are using the blockchain to store data, but if you compromise the thing, as in the Internet of Things, all bets are off. You can still fake information on the blockchain or elsewhere. And then there have been numerous claims that the blockchain is it's a new internet. The problem with using blockchain for distributed calculations is that there is enormous redundancy of computing power. And this means that you have no real parallelism and there's no coordinating operations and thus no efficiency. So it really doesn't make sense. There are other better solutions. And then finally, storage of confidential data. I was sort of touching on this in terms of the use of blockchain for voting. In Europe, we have this challenge with the General Data Protection Regulation, the GDPR. GDPR has this provision about the right to be forgotten. And as I already mentioned, once something is put on the blockchain, it remains on the blockchain. It's a bit like stuff that happens in Vegas. Once it's said, it can't be unsaid, and there's no way to be forgotten on the blockchain. Then, of course, the natural counter-argument in this case is, can we just encrypt everything? Now, the problem with this is that, strictly speaking, an encrypted string can decrypt to anything depending on the key. So, the following text, the answer to life, the universe, and everything is 42, that could be one plain text corresponding to some ciphertext, but it could equally well be Donald is a really nice guy who just wants to have fun. These two are, in a sense, equivalent. They are just they have the same length, and you could easily create a one-time pad which could decrypt to one or the other. It doesn't really. There's no way to prevent that. So it doesn't really help if the blockchain is tamper resistant if I can just change the key. So the encrypted text could be the same, but I could claim that the encrypted text means two different things. And then there's a final question. Will the blockchain replace, or will Bitcoin replace cash? And as you might have gathered by now, I find this to be quite unlikely. There are various attempts, of course, at doing various speed ups. There's the Lightning Network, etc., etc. But all in all, I believe currently that the main thrust of cryptocurrencies are as an investment vehicle rather than a currency. And that actually quite quickly completes my presentation. And I thank you for your attention and to take any questions. Let's see if I can make the Q&A appear here. Yes. Okay, so I have a question from Brian. Will Bitcoin replace gold? That's of course a good question. And it's a philosophical question, because traditionally we have held that gold has some intrinsic value because you can use it to make pretty things, you can use it to create circuit boards, things like that. And so gold has been held to have an intrinsic value. Bitcoin, of course, is just it's just a big number. And there is this question about intrinsic value. So my personal opinion, this will of course just remain an opinion, is that Bitcoin will not replace gold. Let's see. Okay. Just working this. Yeah. So, right. Okay, looking through the question list. So there's a question here. Do you believe that blockchain online voting could address the lack of trust that voters have in existing central authorities? They would hold their votes that might be public for scrutiny. Yes, in the sense that in terms of transparency and so on, of course, that is an argument. However, the problem with that, in my opinion, is that when you don't have anonymity, there's this central concept of the central concept of voting, that you should have anonymous voting. And when you don't have that, you also have the risk of voter coercion and things like that. So that's blockchain could give you something, but I don't believe that it will actually work in the long run. Okay. Let's see. Right. I have another question from George. Does the blockchain size make it self-destructive if it were accepted and used widely? Now, again, a personal opinion. I don't think the size in itself is that important. We will see that the storage capacities available even for consumer computers keeps increasing, and in terms of the mining pools, that's even more so. So I don't think that the size is self-destructive. However, it's more about, as I mentioned, it's more about the consensus algorithms that are used. So proof of work is, in my opinion, unsustainable and will not work in the long run. Okay. Let's see. Okay, so we have a question from Gokula. And asks, is Bitcoin worth gold? I think that relates to the previous question. Bitcoin has no intrinsic value. Bitcoin is worth what people believe it's worth. So it's very difficult to compare. So Kerry would like me to go into more detail on the limitation of voting on the blockchain. I think I already mentioned this. I think that the main problem is anonymity, and that has some tricky aspects. There is a question from Maria. What is blockchain helpful for then? Well, that's a very good question. There are clearly some very good applications of blockchain. But my main problem is that too many people have this almost magical belief in blockchain. So, for instance, I have seen many examples of proposals of using blockchain for supply chain security or supply chain management. The problem with that, or the problem with those solutions that I've seen, is that they have had a primarily pen and paper based system where they have said that, we need to modernize this, we need to digitize this, and then they say, okay, the answer, okay, we can actually, instead of using this pen and paper based system, we'll use the blockchain. That is, again, using a hammer to drive a screw. So it's the wrong, not necessarily the right tool for the problem. In terms of what blockchain successfully has been used for, Bitcoin is a very clear example. It's sort of, up until now, it has been a very successful application. Okay. I have a question from George. Hi, George. What else is hard about blockchain besides distributed consensus? Yes. It, of course, depends on the application. So there are, of course, a number of other challenges. One of the things that I mentioned is anonymity. So if you want to use the blockchain for something which requires anonymity, that is tricky. Yeah. Okay. And there's a question from Sanjay. Is it that no cryptocurrency will replace real money, or is true only for Bitcoin, I assume? No. This is, of course, also something which might change in the future. But then, again, you would need to find some sort of consensus algorithm that is faster than the ones that are in current use. So, for instance, with the and this, of course, also brings me back to George's question. Another challenging thing about at least the Bitcoin blockchain is the transaction time. So it's not currently practical to use Bitcoin to buy a cup of coffee, because you need to. I believe currently the idea is you need to wait for at least 5 blocks to be mined before any given transaction is approved, because you need to have a certain faith that this chain is the longest chain that will be mined. This is a specific about blockchain consensus. Typically, most blockchains have this rule that the longest chain wins. So it's in theory, you can have several people mining on different strands of the blockchain, and then it can then be a bit random which is actually the one that ends up being the longest. And the problem, of course, is that all those orphan chains, at least in the Bitcoin blockchain, are basically discarded. So even though you did a legal transaction and it was recorded on a block and a few blocks on, if there is subsequently a longer chain that mines some different blocks, then your transaction might actually be rolled back and actually didn't happen. So this means that it takes a number of, I don't actually remember the exact time, but as much as a minute or more before you make a payment till it's verified. So in terms of the shopkeeper, how many minutes would you have to wait until you can actually get your cup of coffee? So that is actually a challenging thing. In the future, could very well be that there is some other approach that would replace money, but currently I don't see it. Okay, here's a question from John. Do you think blockchain would be suitable for permanent records, such as school records or police criminal history? Yes, to the extent that this is public. And I guess certainly school records, I have seen proposals that specifically go into this, where they will actually use the blockchain for permanent records. And in that sense, it could actually be a good application of blockchain. So there's a question from Dennis. Blockchain has been posited as a means for securing property transactions. Is there any added value in doing this? Only to the extent that it is a immutable record. So you would you could use the blockchain to record the property transactions, but on the other hand, currently we, I guess all of us, live in regulated societies where we trust our whatever they are called, company's house or whatever, these offices that keep such property records, and as long as you do that, I don't suppose there is a lot of added value. So there's a question from Sean. Can you expand on the problem that quantum computing presents to blockchain? Yes, I can say a little bit more on that. So the problem, as I stated very briefly, is that on pretty much all blockchains, but particularly, of course, Bitcoin, a transaction is basically more or less a formalized statement that says, hello, this is Alice. I want to pay, say, 1 Bitcoin to Bob. And then this is a transaction. This transaction is then signed by Alice's private key. Now, this private key is, well, it could, of course, in theory, could be any public key algorithm. But typically, the ones that are used are conventional in the sense that they are not quantum resistant. Now, the current most common public key algorithms are based on either the difficulty of factoring large numbers, so that's the RSA type of public keys, or it's the difficulty of performing a discrete log operation. That's the Diffie-Hellman type of public key cryptography. And then there are various variants such as elliptic curve cryptography, but they also rely on some of these concepts. All of these that are in common use today, that fundamental problem, either performing the discrete log or factoring a large number, becomes trivial once you have a workable quantum computer. And that means that you could basically fake any transaction that you want to. You could, so if you are Charlie, you can make any transaction saying, hey, I'm Alice, pay 50 Bitcoin to Charlie, and sign it with Alice's key, which you have recovered because you have a quantum computer. Furthermore, excuse me, there's also the issue of the hash algorithms, the cryptographic hash algorithms that are used to perform, in the case of Bitcoin, to create this Merkle root, and also then the hash of the header of the previous block. As I said, once you have a quantum computer, you would need to have twice as large hash sizes as you have today in order to have a secure hash. And with the current hash sizes that are used in current popular blockchains, this simply is not workable. What this actually means then is that once you have a workable, generally available quantum computer, all the current blockchains need to be re-engineered, and you need to start from scratch, basically. And also this immutable property of the blockchains at that point can no longer be assured. So what practical consequence that has for current blockchains is that I think it's pretty clear that they should start now to transition to new signature algorithms and new hash algorithms, basically. Okay, it's a question from Patrick. If I can speak to the claim of Bitcoin anonymity, true versus pseudo, absolutely. So that's also, incidentally, an issue about that also relates to voting, because you could, in a sense, you could have voting that's sort of based on signing things in the blockchain, but there's nothing to prevent you from having multiple identities. So this is certainly the case in Bitcoin. People typically have multiple Bitcoin addresses, or in that case, multiple Bitcoin identities. So, however, there is, from what I've heard, law enforcement agencies generally and routinely trace Bitcoin transactions based on who is paying money to whom, and often are able to trace such transactions anyway, even though multiple identities are involved. So even though in theory you have anonymity, or at least pseudonymity, it may not be that simple, particularly when everything is visible to everyone. Right, so this is a question from Zeja. Why are there no successful commercial use of blockchain in the real world? Well, I would argue that Bitcoin is fairly successful. I think that's also true for Ethereum. So it's difficult to say that there are no commercial applications, but it's true that beyond cryptocurrencies, I haven't yet seen any convincing applications of blockchain in the commercial space. So there are a number of reasons for this, but of course, I've seen many proposals that, for instance, use the Ethereum blockchain as sort of their blockchain to do things. This also has some additional challenges, among them that in order to do transactions on the Ethereum blockchain, generally you need to have a transaction fee. So if you will recall that slide from Gartner about the some of the potentials for blockchain, one of them was low transaction fees. So in the implementation of Bitcoin, initially there was no transaction fee because the miners were rewarded by a number of Bitcoins once they successfully mined a block. Now, the way Bitcoin has been engineered, this reward is actually decreasing regularly. So at some point, the last Bitcoin block will have been mined. There will be no further rewards for mining Bitcoin. And at that point, you will actually need to, in order to verify, to perform the consensus work that you are providing proof for, you will actually need to have transaction fees embedded in your transactions, so that there will be a certain amount paid to the person or the consortium, if you will, that actually verifies a block. So there's a cost involved. So even though one of the arguments for using Bitcoin initially was that, oh, it's so expensive to transfer money overseas, we find ourselves now in a situation where it will be increasingly expensive also to perform Bitcoin transactions, because you have to pay a transaction fee. And there's also this currently bit of uncertainty that you don't really know how soon your transaction will be processed, and it may also be influenced by how much of a transaction fee you're willing to pay. So people who are willing to pay higher transaction fees will find their transactions being processed quicker. And that's maybe the issue with many of the applications that propose to use Ethereum, is that you have to spend a certain minimum of so-called gas, this transaction fee. And of course, that's maybe less of an issue if you are transferring thousands or millions of dollars. But if you want to build an application that is kind of an Internet of Things sensor that sends data on the blockchain, then having to pay gas for every little transaction, that quickly becomes, well, if not unworkable, at least unprofitable. Okay. Let's see. Okay, so we have a question from Katarina. Regarding supply chain management, you can come to a point where you don't know all the parties nor trust all of them. Another option to using blockchain would be to create the trust using a central authority. Yes, indeed. So, for instance, my example of authenticity of drugs, for instance. One thing that you could do is that you create some sort of international registry of drug manufacturers, and each manufacturer registers with this registry and then receives or somehow acquires a certificate, and then they can sign their whatever, I guess some ID on, in theory, on every package of pills that they sell. They can have a unique ID that you could sign. You would also then, of course, need to have some way to verify that that specific package hasn't cropped up in many different places around the world, because that would be an indication that there is fraud involved. So it's not necessarily straightforward, but there is an option there. Yeah, so there's a question from Wei. Do you think it will be possible to design a new, reliable, scalable, and efficient consensus algorithm? Yes, although I can tell you it will not be me who does that. This is work for mathematicians and combinatorics experts. It's, I believe, still going to be a hard problem, but eventually they managed to solve Fermat's last theorem. I think this is also something that eventually might get resolved. So we have another question from Kaori. What would be the best use case example using blockchain? I think, like I already said, that's still currently cryptocurrencies. Yeah, but in general, I think that beyond cryptocurrencies, I have yet to see this best use case. So, but something that is definitely worth looking for. So we have a question. It's a question from Paul. Are these 5 things the only things for which you cannot use blockchain? I think the answer is no. So why pointing them out among others? That's a valid question. Of course, it's not been my intention to provide the exhaustive end-all list of things that you cannot use blockchain for. And also remember that much of this is my opinion. I would be quite happy to be proven wrong on some of these, but currently this is what I believe. So my main goal with this presentation is not necessarily to provide this definitive list, but rather to problematize the concept that you can use blockchain for anything, which I believe is incorrect. So there's a question from Hanan. Hi, Hanan. Nice to have you here. Thank you for this interesting presentation. I don't personally work on blockchain, but I'm interested to know your opinion about what aspects should research focus on in terms of blockchain. I think, as I already said several times, consensus algorithms, that to me seems to be the big void at the moment. This is where we need to put some hard work, and it needs to be, unfortunately, it needs to be mathematicians and those kinds of people. But of course, it's always good to have some hard problems to keep the mathematicians off the street. So there's a question from Eric. So you are saying there are multiple types of blockchain or one big blockchain with smaller subsets? No, definitely there are multiple blockchains, and if you want, you can create your own blockchain, and there's nothing to stop you from doing this. Now, for instance, the Bitcoin blockchain, that's one big blockchain, and it keeps growing. I can't actually remember what the size is currently, but I think it's in gigabytes. So gigabytes of transactions stored on somebody's hard drive. But the Ethereum blockchain, yet another one, and then there are any number of blockchains. And there are also things like the IBM Hyperledger, which is a blockchain which is not based on a cryptocurrency, or not primarily used for cryptocurrency. And there are various others. So there are any number of blockchains. And here's a question. Will blockchains be helpful in the healthcare system? They're already discussing about standardization. Yes, so this is asked by Ulrich. Yeah, it's definitely the case that there is a lot of standardization going on. In all kinds of applications of blockchain, there are standardization efforts. doesn't necessarily mean that all these will be applications that I would categorize as good or even useful. So to quote Andrew Tannenbaum, used to be a professor in Amsterdam, the good thing about standards is that if you don't like one, you can always find another one. There's a question from Frank. The Fed could create and manage a true cryptocurrency as they do US dollar. Why wouldn't that be of value? Yes, that would be, in a sense, would be the same as paper money, because the paper money that you use is somehow backed. This is the concept of fiat currency. So there is a government saying that, okay, I don't actually recall what it says on the US dollar. I do know that on the Norwegian currency, up until 50 years ago, it said that if you take this note to the Norwegian State Bank, we will pay you this amount of gold. And this is the concept of currency, or used to be the concept of currency. Of course, these days, money is basically also just zeros and ones, just entries in somebody's or some bank's accounting system. And in that sense, yes, absolutely, you could have fiat blockchain currencies. However, you still have those issues with consensus algorithms and possibly transaction times, etc., that you would still need to worry about. And of course, currently, when you pay with cash, that's it. You hand over your cash and you're done. Eventually, you might not be able to do that with a cryptocurrency, because every time you buy something, you might also have to pay a transaction fee. However, I might guess that for some Americans, that's not much of an issue, because when you go to the store and buy stuff, you get your sales tax added on to your purchase, which is for many Europeans often comes as a surprise. So that might be the same thing. Okay, still have time for some more questions. There's a question from Kalpana. Does blockchain have a future? Yes, I would say so, but I wouldn't necessarily be able to tell you what that future is. It remains in the future. And we have another question from Ava. Do you think that Bitcoin have a potential to have a role in shared business like cloud kitchens? If I only knew what a cloud kitchen was. But yes, certainly, if I just stay in shared businesses, that could definitely be the case. But I guess I would have need to know what a cloud kitchen is to answer that properly. Right. Let's see. So there's a question from Spy, I guess, if that's how it's pronounced. Could you have anonymized voters? Yes, but the problem, of course, is the problem is the voter registration aspect. So the way voting, at least in my country, works is that you have to actually identify yourself. So you have to show some form of ID, and they will cross you off in the voter registry. And once you've done that, then you get to go and give your anonymous vote, but not until you do that. So in order to use blockchain for voting, you have to solve that question. I don't actually see how you do that. Let's see. That's a question from A. Ferraro, and yes, I can confirm that the slides will be available after the presentation. So there's a complicated question from Ignacio. Hope I can answer it. Would you recommend such things as highly available distributed databases with ACID transactions where users, actors, agents have, e.g., digital signatures as identities as viable alternatives to some of the 5 non-use cases that you cited in your presentation? Yes, I think the answer to that is yes. Now, for instance, to take the supply chain example as one of them, I believe that currently it would work just as well to have all these various actors. So the manufacturer, the transportation company, whatever, ports, etc. They could all basically use signatures to do the same thing that you otherwise would do with the blockchain, because you could easily have some trusted third party that can fulfill this registration purpose. Right. Still have time for a few questions. Let's see. Yeah, so the question from Miguel is, what weaknesses does blockchain see in underdeveloped countries that do not have the infrastructure for this technology? Yes, that is, of course, an issue. Also relates a little bit to this thing about connectivity, because in order for a blockchain to work sensibly, you need to you need to have a minimum connectivity, minimum bandwidth, and of course, if you don't have, for instance, if you cannot rely on people having access to internet, definitely a challenge. However, what we see in some countries that we consider maybe underdeveloped is that they have, to a certain extent, leapfrogged the technology in the sense that they maybe don't so much have personal computers, but they do have cell phones and even smartphones. So that some of these economies are actually they are able to access blockchain-based, or in theory, could do that. Yeah. So the final question. Yeah, I'm sorry about not being able to answer all of them, but this is the final question. It's from Krishnamurthy. Blocks have hashed and encrypted data. To check the contents, we need to unhash as well as decrypt data, don't we? How does one get these things? Now, that's not actually the case. For instance, in the Bitcoin blockchain, the transactions are in clear text. So you can actually read them out directly, but they are signed. So there's a signature appended to each transaction, and then when a block is created, there is created this so-called Merkle hash tree, where each transaction is hashed using the designated hash algorithm, and then the next transaction is also hashed using the same hash algorithm, and then these two hashes are concatenated and hashed again and passed up the tree. And so at the top of the tree, we find ourselves with what's known as the Merkle root. You need to do this in order to verify the block, but you don't need that to actually read out the content. So that completes the Q&A for now, and I will hand over to Kerry.
Yeah, thank you very much, Dr. Jotun. The number of questions that were coming in definitely says that this was a great conversation. I wish that we could get to all of them. I think it would take us about 3 or 4 hours just to get all of the questions through. So that was great. Thank you very much. I'd also like to thank everybody for attending today. The next webinar in the Distinguished Lecturer webinar series is on the 9th of July at 11 a.m. U.S. Eastern Time. Lionel Sosa will cover unconventional computer arithmetic for emerging applications and technologies. On the 16th of July, we'll have a webinar on smart and circular cities, status, trends, and opportunities, presented by Dimitrios Serpanos, professor of electrical and computer engineering at the University of Patras. This webinar will be co-sponsored by the STC on smart and circular cities. In addition to the Distinguished Lecturer webinar series, we also have the Build Your Career webinar series that focuses on business soft skills such as communication and presentation skills, career transition, interviewing tips, among others. Our next Build Your Career webinar will be on the 22nd of July at 11 a.m. U.S. Eastern Time on Lead Yourself First by Adam Schmidt, CEO and Principal Coach at Smart Summit Coaching LLC. Registration for these is now open, and we will be sending you a link to these future events along with the slides and recording of this webinar. Again, thank you very much for coming, and Dr. Jotun, thank you for your presentation. It was great.
Thanks for having me.